Welcome to the Glassworking Shop. Today I'm going to be testing for the very first time my new assembly fixture for putting together chip stacks of marine slices. Let's talk about chip stacking. When I first started chip stacking, I used the method that I had seen in videos and that some of my teachers had showed me, which is to put the first chip on a punty and then assemble the remaining chips using tweezers. This just didn't feel natural to me, and I never got really good results, so I decided to try doing it on a platform. First platform that I used was a piece of mild steel. Put the pieces on it, put it in the kiln, heated it up, and then attempted to stick them together with graphite tools and a hand torch. Of course, there were a number of problems. Mild steel gets kind of crusty and corroded when you heat it up, and if you get it too hot, it sticks to the glass. I tried some kiln wash, and that didn't work really well. I even got an unbelievably expensive piece of what they called high-temperature ceramic material from McMaster Carr. It cracked. Then I tried a piece of, I guess, a ceramic, what they call a kiln shelf, and it worked okay, but it was kind of dirty and dusty, and it cracked. Next test was to use a piece of stainless steel. It was a whole lot better. It didn't corrode, it didn't get all crusty, it did warp a little bit after making a number of objects. Next step was to use graphite. This is a half-inch graphite, and it's got some holes in it so that I can push up against things. And this worked pretty much the best so far. Today's invention, which I'm going to be using for the first time, is a little bit more sophisticated and engineered assembly fixture for putting marine pieces together into a chip stack. The frame is made of steel, mild steel. It's elevated so that it won't burn up my bench when I'm heating it, and also the heat won't be sucked out of the surface into the bench and kind of isolate the heat a little bit more to the chips being stacked. And hopefully the test will go well. The new assembly fixture has stainless screws threaded into graphite. Hopefully they won't get stuck when they get hot. Each of the stainless screws has a recess drilled into it that I can insert graphite rods of various different lengths. The plate that the chips sit on is also graphite. And for the first test, I'm going to be using just a socket on the end of an extension for adjustment if any adjustment is necessary when it's hot. But in the future, I may design some kind of a clever little thumb screw kind of thing that can be operated with gloves. In order to put it in the kiln, take it out of the kiln, and prepare it for use, I've got this metal fork thing, and it comes right off like that, and the base is somewhat universal, so I can still put my older designs back on it if they turn out to be useful for the work being done. So that's today's project. Let's go out in the shop and begin some preparation. I need to make a border. Let me put this guy back on here and describe what's going on. These patterns typically have a border that goes around the outside. The border is made of hexagons, which are cut to rough shape and put into place and then fused together. The piece of hex solid material was the piece that I made in yesterday's video, and today I'm going to go out to the cold shop and cut the pieces to size, and then hopefully fuse them together with great success. So here goes. I'm out and back in the cold working shop, and I'm going to cut up this piece of cobalt hex, solid cobalt hex that I made yesterday. Using my new prototype 10-inch wet saw, which actually works really, really well. And let's get some water going here. Okay. The saw is designed to be more than just a simple saw. It's designed to be a precision cutting instrument, and as the design evolves, I'm hoping that it can approach the accuracy of machine shop tools. The table slides on precision linear bearings, which of course are protected against the glass dust and the other mess that usually accompanies a cold saw. Right now I've got an adjustable stop hooked up to the table. There's lots and lots of threaded holes for attachment of various other devices, and I've got lots of ideas for a variety of different precision holding devices to be able to hold glass and cut it in a very precise way. Clean up the wheel a little bit, and then it's into production. Oh yeah, that's cutting better. Okay, so there's the pieces rough cut to size, and as you may have guessed, it's unlikely that they're going to fit perfect. So next step is over to the lap wheel, and let's adjust them and make them fit. They don't have to be perfect, but get them to fit a little bit better than they fit just off the saw. These pieces don't need to have a lot of material removed from them, so a fine grain wheel will probably be just fine. Get the pieces ready here. The lap wheel is another one of my designs. Seems to be working really, really well. It has center feed for the water, and probably put the cutting disc on a little bit crooked. Try to figure out what's going on with hot glass and a hand torch in my hand. I think the fixture is going to make things a lot more controllable. And there we have it. Now the next step is put it in the kiln, get it hot, and fuse it together with a hand torch. Okay. Hopefully my microphone is adjusted a little bit better so I don't get any of that awful breath sound. Looks like the kiln is just about up to temperature. Tools are ready. Got the support plate positioned in a convenient place. The Inquala isn't being used for this, and so it's out of the way. Torch is moved over to the side. Really cool thing about the Unistrut is that I can move stuff around. First step will be kind of get the thing hot. And of course I'm doing everything slowly and carefully because there's some fairly sensitive colors in here and I don't want to boil them. Usually I start in the center of these patterns and work outward. When you heat a pattern like this, the edges of the glass tend to round off. And in order to get that, I gotta get my hose control a little bit more under control. I made a little graphite push tool, kind of got a little rounded end on it like that. And that'll help barely, gently, to push those rounded edges together and cause it to fuse without distortion. Once again, the key to making this process work is be gentle. As I've learned by painful experience, it's very, very easy to distort the pattern by being too heavy-handed. You know, a little bit more fire here. I'm just very gently pushing these pieces together. Okay, so that pretty much gets the center portion of the design under control. It's not perfect yet, it's not perfectly fused, and if I took it out and let it cool, it would certainly crack apart. There's much more heating to go and much more shaping to go, but the preliminary fusing has been completed on the top surface in the center. Now I'm going to start moving around to the edges, the pieces that were cut and adjusted on the lap wheel. I don't have a tremendous lot of glass thickness, so I need to make sure that the surface is reasonably flat. so I don't have to lap away too much and end up with a really, really wafer-thin piece. Okay. Preheat this guy so I don't shock it. Preheat the tweezers a little bit. The reason I took it out of the fixture is a couple of things. First of all, I need to turn it over, and second of all, I'll be using the flat paddle, and can't really get flat with all that clamping stuff in the way. Nice thing about doing this on graphite, it doesn't stick to the plate. When I was using stainless, I had to be fairly careful and fairly aware of, is it getting too hot? It's going to stick to the plate. Okay. So now, let's flip it. Flip it good. Ba-na-na-na-na. Bum, bum. And there we have it. 1/8. Off to the kiln. Thank you for watching. It's been fun.